Welcome students for our lecture 3. Today we are going to discuss statically determinate and indeterminate structures. Before that, we would like to go back and in our first lecture, when we started this particular course, we have seen the basics in structural analysis. That is, what do you mean by axial force? What do you mean by shear force? What do you mean by bending moments? And we have seen the sign conventions. In the same lecture, we have seen the basics about types of supports, types of loads, and types of beams. We have seen propped cantilever, simply supported beam, overhanging beam, cantilever beam, continuous beam. We have seen. In our second lecture, we have seen basics of loads, types of supports, and types of beams. In our second lecture, we have seen types of supports, what do you mean by various types of beams. This what we have seen. And then today we will proceed to go for determinate and indeterminate structures, statically determinate and indeterminate structures. For those who are watching this for the first time, let me remind you the link for joining the course is in the description. You can join this 12 weeks course basics in structural analysis when we are going to rebrush about the basics in structural analysis, and we are going to learn a few simple classical methods in structural analysis. We may think of advanced structural analysis at the end of this course. So today we will concentrate ourselves on statically determinate and indeterminate structures. So we have seen in our previous lecture various types of beams. So first type of beam we have seen is simply supported beam. We have seen simply supported beam, and the simply supported beam, all of you must have remembered, or all of you must have noticed the simply supported beam. It looks like this, that one of the ends is hinged and other end is roller. It looks like this. One of the ends is hinged, other end is roller support. So simply supported beam. Now, how many number of reactions in our previous lectures we have seen? Number of reactions possible for hinge support are 2. Hinge support, there are 2 possible reaction, and roller support, number of possible reactions is 1. So total number of reactions is equal to, number of reactions is equal to 3. In case of hinge simply supported beam, total number of reactions is equal to 3. This is one type of beam we have seen. Second type of beam in our previous lecture we have seen is known as overhanging beam. Is known as overhanging beam. In this particular structure, the one of the supports is hinged, the other supports is roller, and third end is free. Other support is roller and the third end is free. Again, in this, the number of reactions, if we calculate, hinge support will offer 2 reactions to the applied loads. The roller support will offer 1 reaction to the applied loads. So the total number of reactions in this is equal to 3. The number of reactions is equal to 3. So total number of reactions in this particular beam is equal to 3. Okay, and the third type of beam we have seen up in our previous discussion, if you refer to the previous discussion, is known as cantilever beam. This is cantilever beam. The third type is cantilever beam, and let us see, one of the ends is fixed and other end is free. In cantilever beam we have seen one of the ends is fixed and other end is free. We have seen fixed support offers 3 reactions like this. The fixed support offers 3 reactions, right? In the first lecture we have seen, and free support do not offer any reaction. So in case we can see number of reactions is equal to 3. Number of reactions in cantilever beam, number of reactions is equal to 3. So common things in all the 3 types of beams, that is simply supported beam, overhanging beam and cantilever beam, is number of reactions equal to 3. This is what we have seen. Now the fourth type of beam, let's understand, we have seen is a continuous beam. In our previous discussion, in our previous lecture, fourth type of beam we have seen is a continuous beam. We have seen many types of continuous beam. For our reference, we can assume that, let us say, this is the type of continuous beam. One of the supports is hinged, other supports are roller supports, and the ultimate support, the last support, intermediate 2 supports are roller supports, and the last support, end support, is again hinge support. Now how many number of reactions are possible in this? we have seen the supports and reactions. Hinge support will offer two reactions. Roller support will offer one reaction. This roller support again offer one reaction. How many? This hinge support will offer two reactions. So total number of reactions in case of continuous beam, we can calculate number of reactions in case of continuous beam is equal to, we can calculate 2 plus 2 plus 1 plus 1, 2 here, 2 here. End support will offer two reactions and single reactions will be offered by the intermediate support. So that is equal to 4 plus 2, 6. So number of reactions is equal to 6. One more type of beam, continuous beam, we have seen is propped cantilever. In our previous discussion, previous lecture, we have seen propped cantilever, in which we have seen one end is fixed and other end is resting either on a roller support or a hinge support. Let us say it is resting on a roller support. One of the ends is fixed, just like a cantilever beam, but the cantilever beam, one support is fixed and other is free. In this propped cantilever, one of the supports is fixed and other is either roller or a hinge. So we know number of reactions at the fixed support are 3 and number of reactions at roller support is 1. So we can calculate total number of reactions in case of propped cantilever. Total number of reactions in case of propped cantilever is equal to 3 plus 1, that is 4. So total number of reactions in propped cantilever is 4. And last type of beam, last in previous lecture we have seen, is fixed beam. This is the fixed beam. This we know is a fixed beam. We call it as fixed beam. When both the supports are fixed, we call it as fixed beam. And then we can see the number of reactions equal to 1, 2 and 3. Fixed support will offer 3 reactions. This fixed support will also offer 3 reactions. So total number of reactions is equal to 6. 3 plus 3, 6. So number of reactions offered will be equal to 6. So my friends, in our static analysis of any structure, we know the number of equilibrium equations. The unknowns are reactions. In static analysis, unknowns are reactions. Once we determine the reactions, we can plot the shear force diagram and bending moment diagram and all other things, axial force diagram, once we determine the reactions. So unknowns are reactions. Unknown are reactions. And what are the known things? The known things in our static indeterminacy, or in case of static analysis, the known things are number of equilibrium equations. The known things are number of equilibrium equation. The equilibrium concept is introduced to you in our basic mechanics course as well as in structural mechanics course. So number of equilibrium equations are the known things and unknown things are reaction. Now let me give you an example. If I say A plus 2B plus 3C is equal to 10, 2A plus 3B plus 4C is equal to, let us say, 15, and 3A plus 4B plus 8C is equal to 100. Now, my friends, there are three unknowns in these equations. Let's talk something about mathematics. There are three unknowns in the equations A, B, and C, and there are three equations. This is equation number 1, equation number 2, equation number 3. Three unknowns with three equations can be solved, and we can get the value of A, B, and C very easily. We can solve these three equations with three unknowns and get the value of these. Now, if I add one more unknown, let us say 4A, here I add 4D rather, sorry, 4D, 6D, and here I add 10D. And if I say these are the equations, three equations with four unknown, then we must know that we cannot determine the value of A, B, C, and D. There are four unknowns and there are only three equations of equilibrium. We cannot determine the value of A, B, C, and D. No. If we have got only three equations and three unknowns, we can determine the value of A, B, C. But if there are four unknowns and three equations, we cannot determine the value of A, B, C, and D. This means what we want for the number of unknowns equal to number of equations. number of unknowns must be equal to number of equations. Number of unknowns must be equal to number of equations. In that case only we can determine the number of unknowns. The value of the unknowns can be determined if number of unknowns equal to number of equations. Now look at the cases. Now look at the cases one by one. Now we know there are only three equations of equilibrium in static analysis. In static analysis, we have got only three equations of equilibrium. What are those equations of equilibrium? We have seen in two dimensions. In two-dimension static analysis, we can get only three equations of equilibrium. We'll talk about three-dimension analysis later. These equations of equilibrium are summation of forces in x direction equal to 0, summation of forces in y direction equal to 0, and summation of moments about the z axis is equal to 0. Let us say this is my x axis, let us say this is my y axis, and let us say the z axis is protruding inside this plane, or let us say it is protruding outside the plane like this. This is z axis. So three axes, we are dealing with xy plane, we are talking about xy plane. Then in static analysis, we know the number of equilibrium equations are limited only to three. That is, summation of fx is equal to 0, summation of forces in x direction is equal to 0, summation of forces in y direction is equal to 0, and summation of moments is equal to 0. These are the only three equations in static analysis. Now, these are the three known things, and we know number of reactions are unknowns. If number of reactions are 3 and number of equations are 3, can we say we can find out all the reactions using equations of equilibrium alone? These are three. This means this is a determinate structure. So we can define a determinate structure. Determinate structure is the structure, statically determinate structure is the structure where we can determine the reactions using number of equilibrium equations alone. So this is my determinate structure. Determinate structure is the structure when we can determine number of unknown reactions using equations of equilibrium alone. Here number of reactions are 3 and number of equations are 3. So we can determine the unknown reactions by using equations of equilibrium alone, and that is why this structure I will rate as determinate. Simply supported beam is a determinate structure. Let's talk about overhanging beam. Overhanging beam, again, number of reactions are 3 and number of equilibrium equations, we know equilibrium equations for two-dimensional static analysis are 3. Number of equilibrium equations are 3. So we can also determine all the reactions in overhanging beam using equations of equilibrium alone, and that is what we term it as determinate structures. That is what we term it as determinate structure. So again, I will mark this structure as determinate structure. That is, number of unknown reactions can be determined using equations of equilibrium alone. So overhanging beam in my case is my determinate structure. Now let us talk about the cantilever beam. Again, we know equilibrium equations in two-dimensional static analysis are 3. Equilibrium equations in two-dimensional static analysis are 3, and number of unknown reactions are always unknown. So number of unknown reactions are 3, number of equilibrium equations are 3. So cantilever beam is also termed as determinate structure since all its reactions can be determined using equations of equilibrium alone. So this is also a determinate structure. I can say I can determine the number of reactions, and I must tell you that once we determine number of reactions, we can plot shear force diagram, bending moment diagram, axial force diagram, which will be the topic of discussions in our next lecture, to plot simple shear force, bending moment, and axial force diagrams for various types of structures. So number of reactions equal to 3, number of equilibrium equations equal to 3. This means this is a determinate structure. Now let's go to the fourth, continuous beam. Now continuous beam, we know that number of reactions we have seen equal to 6. But how many equilibrium equations, how many static equilibrium equations are available in two-dimensional structure? In case of static, equilibrium equation available is equal to 3. This is as good as this case, that only 3 equations are available and number of unknowns are more than 3. If number of unknown reactions are more than 3 and only 3 equations are available, we cannot determine the reactions, because it is as good as determining the value of A, B, C and D with only 3 equations at our disposal. This means we cannot determine the number of unknown reactions. So these structures are known as indeterminate structures. These structures are termed as indeterminate structures. So this is an indeterminate structure. I will term this as indeterminate structure when number of unknown reactions cannot be determined using equations of equilibrium alone. So these structures can be termed as indeterminate structures. So continuous beam is an indeterminate structure. Let's go to propped cantilever. We know number of equilibrium equations, they are constant. Static equilibrium equations in two dimension is equal to 3. So number of equilibrium equation equal to 3, but number of reactions, unknown reactions are 4. So this is also the propped cantilever is also termed as indeterminate structure. Indeterminate, because this is as good as solving four unknowns using three equations. Just like this, we have seen that a plus 2b plus 3c plus 4d equal to 10, 2a plus 3b plus 4c plus 6d equal to 15, and 3a plus 4b plus 8c plus 10d equal to 100. We cannot find the value of a, b, c and d. Same is the case over here. So this structure is also termed as indeterminate structure. So the propped cantilever is indeterminate structure since number of reactions are more than 3 and number of equilibrium equations, two-dimensional equilibrium equation available at our disposal are 3. And same is the case with the last, that is fixed beam, that is number of equilibrium equations are 3. They are limited to 3. Summation of forces in x direction is equal to 0. Summation of forces in y direction is equal to 0. And summation of moments acting in xy plane is equal to 0. We are talking about two-dimensional structure. So we are working in xy plane itself. So summation of moments in xy plane, that is moments about z axis, they will act in xy plane. So that is equal to 3. Only 3 equations, and there are 6 reactions. 6 reactions to be determined. 6 unknown reactions. So this fixed beam is also termed as indeterminate structure, where we cannot determine the number of unknown reactions using equation of equilibrium alone. So this is the basic difference between determinate and indeterminate structure. But my friends, let me tell you one thing. There is a concept called as internal hinge. Let's understand the concept of internal hinge. There's a concept called as internal hinge. Let's understand the concept of internal hinge. Let us say this is a propped cantilever. I will take the example of a propped cantilever. I will take the example of a propped cantilever. Here it is roller, and let us say there is an internal hinge in the structure. I will say this is an internal hinge in the structure. Now, my friends, basic number of equations are 3. Summation of forces in x direction is equal to 0. Summation of forces in y direction is equal to 0. Summation of moments acting in xy plane is equal to 0. Now we know the number of reactions, number of unknown reactions in case of propped cantilever is 3 for the fixed support. So number of reactions is equal to 4. Propped cantilever, number of reactions 3 for the fixed support and 1 for the roller support. Number of unknown reactions equal to 4. Now we know the basic equations of equilibrium. Equations of equilibrium, two-dimensional static equations of equilibrium, static equilibrium equations. We are talking about two-dimensional structures. So static equilibrium equations, two-dimensional static equilibrium equations are 3. But my friends, every internal hinge, I must tell you, whenever it comes to an internal hinge, every internal hinge will provide one additional equilibrium equation. Internal hinge will provide one additional equilibrium equation. Every internal hinge will provide one additional equilibrium equation. Additional equilibrium equation. Additional equilibrium. What is that equation? We'll see. Every internal hinge will provide one additional equilibrium equation. What is that equation? Summation of moments about the internal hinge is equal to 0. Summation of, let us say this point is C, then summation of the three equilibrium equations at our disposal is summation of forces in x direction is equal to 0. Summation of forces in y direction is equal to 0. summation of moments in xy plane is equal to 0, and one additional equation given by the internal hinge, that is summation of moments acting at internal hinge is equal to 0. So every internal hinge will provide one additional equilibrium equation. Now this is the case that there are four unknowns. Reactions are unknowns, unknowns are reactions. This is the case, that is A plus 2B plus 3C plus 4D is equal to 100. Let us say 2A plus 4B plus 8C plus 11D is equal to 150, and let us say 3A plus 6B plus 4C plus 10D is equal to 175, and last equation 4A plus 6B plus 8C plus 20D is equal to 200. If these are the equations, now there are four unknowns, A, B, C and D are unknowns, and there are four equations. This is equation 1, this is equation 2, this is equation 3 and equation 4. We know whenever number of unknowns match with number of equations, the structure becomes determinate. Same is the case here. Number of unknowns in number of reactions, or number of unknowns in this case, are 4. Number of unknowns are 4. Number of reactions, these are the number of unknowns, are 4. And how many number of equilibrium equations we have got? 3 classical equilibrium equations for two dimensional: summation of forces in x direction, summation of forces in y direction, summation of forces, summation of moments about xy in xy plane, that is about z axis, is equal to 0. And the fourth additional equation is generated by the internal hinge. Every internal hinge will provide one additional equation. So this propped cantilever will become determinate. So we can say this structure has become now determinate. This is the determinate structure. This propped cantilever has become determinate once it has been provided with one internal hinge. So this is statically determinate. So this is the internal hinge, and this structure now has become determinate structure. Earlier we have seen the propped cantilever without any internal hinge. This was the case we have seen. Without any internal hinge, number of reactions, number of unknown things were 4, and number of known things, number of known equilibrium equations were 3. So this was indeterminate in nature. But we have seen, once we have provided the internal hinge, every internal hinge in the structure will give one additional equilibrium equation, and the structure becomes determinate. Now let us understand this concept by solving one more example. Let us say this is any portal frame with hinge supports. At present, hinge supports at both the ends. ABCD is a portal frame. Hinge support at A, hinge support at D. So there are how many reactions? Let's judge how many number of reactions are there. There are four reactions. One hinge support will give you two reactions. Another hinge support will give you two reactions. So number of unknowns, or number of unknown reactions, I will say reactions are always unknown. We need to determine the reactions. Once we determine the reactions, plotting SFD, BMD, axial force diagram becomes very simple. Number of reactions are 4, and at present, if we look at the frame, number of equilibrium equations are 3. So this may be an indeterminate structure. But if I say that B is an internal hinge, if I propose that B is an internal hinge, if we suppose that B is an internal hinge, if we provide one internal hinge at the support, then my equations, number of equilibrium equations becomes, initially number of equilibrium equations for two dimensional structures are 3. Number of equilibrium equations two dimensional structure, basically they are 3. Summation of forces in x direction equal to 0, summation of forces in y direction equal to 0, and summation of moments in xy plane is equal to 0. There are 3 equilibrium equations initially, but in this case, this proper case, one additional equilibrium equation is given by the internal hinge, that is summation of moments about the internal hinge is equal to 0. So total number of equilibrium equations become 4. So what can we conclude? That we can conclude that this structure is a determinate structure, where we can determine the number of unknown reactions using equations of equilibrium alone. So this is all about determinate and indeterminate structure. Let me tell you, my friends, most of the structures in nature, or most of the structures constructed, are indeterminate in nature. Why they are indeterminate in nature, that we will discuss in our next discussion, determinate and indeterminate, and why indeterminate structures are preferred. And most of the methods we are going to learn are the analysis of indeterminate structures. So we are going to learn indeterminate structures. We are going to deal with indeterminate structures more often than determinate structures. We will see what is the difference between determinate and indeterminate structures, and what are the advantages of having the structure indeterminate. Though they are somewhat difficult to analyze, not so difficult, we are going to learn the methods to analyze indeterminate structures. So indeterminate structures, why they are preferred in practice, that we will see in our next lecture. Once again, to remind, if you are listening to this for the first time, you can join the course. You are using the link which is given in the description of this video, and then you can enjoy getting these videos one after another, and we will start from simple things, and at the end of this course you will find you are well equipped with number of methods to analyze indeterminate structures. Thank you for watching.